Hello student, today we are going to study about the importance of third law of thermodynamics. In the past lecture, we have studied about what is entropy, what is enthalpy, and the statement of third law of thermodynamics. And in this lecture, we will study about the importance of third law of thermodynamics. In the exam, the question may be asked in the two form. In the one way, the question may be asked, explain the importance of third law of thermodynamics. And in the next way, the question may be asked as, how do you use third law of thermodynamics to calculate the absolute entropies of solid? If such a question is asked, we have to derive the equation, we have to derive the formula, we have to show the statement as follows. Here, what infinite symbol entropy change ds is equal to dq by t. It is written as equation 1. This is equation 1. We have the relation ds by dt is equal to, this is capital C, capital Cp by T. You know Cp is equal to heat capacity of a substance, and ds is equal to Cp by T, and this dt on this side, dt, yeah, ds is equal to Cp dot dt by T. Now integrating on both sides, we get ds is equal to Cp dot dt. In this side, ds side, we integrate. In the lower form, we had s0, yeah, initial, and this is the final st. This is the final st is equal to, and in Cp side, in the right hand side, we take initial temperature is equal to 0, and the final temperature is taken as T. Then Cp dot dt by T. Here, when you integrate this ds, we get st minus s0 is equal to, this is 0 to t, it remains as it is, Cp, and dt by t changes into d ln t. And we know s0 is equal to 0. So s0 is equal to 0. So st, it comes as it is equal to 0 to t Cp d ln t. It is symbolized as equation 2. If the temperature is less than 20 Kelvin, then the heat capacity of the solid is given by the relation. Heat capacity is taken as Cp is equal to AT cube. We can directly, without writing this, also we can write that, only we can write heat capacity is equal to Cp is equal to AT cube. A, this is T, and Q. Putting the value of this is Cp in equation 2. We know putting the value of Cp in equation 2, we get St is equal to 0 to 2. In terms of Cp, we write AT cube and d ln t. Now St is equal to A, this is 0 to t, t cube by, this is t, dt is equal to, it becomes t, 1 t cancel, and A, this is a constant term A, t square dot dt. St is equal to a constant term. As it is, we have written it here, but it is not necessary to write. We can write it directly this also. But to make it easier, I have written this St is equal to a0 to t square dt. This same is equal to a t cube. A is a. When we integrate t square dot dt, we get t cube by 3. Here, this is the formula as n this is 2 plus 1 by 2 plus 1. This temperature T is equal to 2 plus 1 by 2 plus 1. Yeah, this is the formula of integration. And AT cube by 3. We know AT cube is equal to CP. And in terms of AT cube, we write CP by 3 and 1 by 3 dot CP is equal to a 1 by 3. It is not necessary to write, that is enough. Yeah, and hence the absolute entropy is 1/3 of the heat capacity of the solid. This is 1/3. This 1 by 3 is 1/3. We can write 1/3 of the heat capacity. Yeah, St is equal to, that is 1 by 3rd. Heat capacity means Cp. This is heat capacity. And this is 1/3. This is absolute entropies. I hope, student, you understand this. Whenever you ask the question, write the importance of third law of thermodynamics, then you have to show this relation. That is, absolute entropy is 1/3 of heat capacity of the solid. If you want to show this in a graph, you can show in the x-axis. This is y-axis. In the x-axis side, write ln T, and in the y-axis side, write this is Cp, heat capacity. And when you put the values of ln T and Cp, we get the curve which is shown in the figure. I hope, student, you understood this my lecture, and in the next lecture we'll discuss about Helmholtz equation. And I hope you understand this lecture and subscribe my channel to get the new videos. Okay, thank you, student.